So today we are going to learn about systems of equations. So what are systems of equations? Systems of equations are two or more equations. And in a system of equations, you are looking for one, the equations, the same. Okay, so Derek scored 30 points in a basketball game. He played without going to the free throw line. That means that Derek scored 2 points in 3-point shots only. List as many combinations of 2 and 3-pointers as possible. Okay, so I'm going to say that my number of 2-pointers is X and my number of 3-pointers is Y, just for the sake of the setup and the problem, and so we can be consistent in the next table. So if I know that he scored 30 points total, so I know that this combination has to give me 30 points. Okay, so let's take a minute and think. If he scored, and we'll start with something simple like 0. If he scores 0 2-point shots, that means all of his points came from 3-point shots, and 30 divided by 3 is 10, so that must mean he scored 10 3-pointers only, no 2-pointers. Okay. The next thing we can talk about. Okay, so let's do. So we know that this number has to be divisible by 30. So if I do 3 2-pointers, I know that that's 6 total points. So I can do 30 minus 6, which is 24, and then divide that, and I would get 8. So if I know 3 2-pointers and 8 3-pointers, they'd get 30. Okay? And then I can do 6 and 6, 9, 4, 12 and 2, and 15 and 0. Okay, so that's kind of all the combinations that are possible for 2 and 3-point shots. Okay, and you should have come up with this if you did this with your group. All right, so then I want to look at a different constraint. So then Derek tells you that the same number of 2-point shots that he made is 5 more than the number of 3-point shots he made. How many combinations can you come up with? So let's think about this. If he made 0 3-point shots, how many 2-point shots did he make? Well, he made 5. Okay, if he made 1 3-pointer, he made 5 more, so 6. And if he made 2, he'd go 7. He'd always have 5 more. And then we go 3, made 5 more, that's 8. 4, made 5 more, that's 9. 5, made 5 more, that's 10. Okay, so there's my number of 2 and 3-point shots, and this has to be 5 more than that. Okay, so now we have our tables that show both of these relationships. I'm going to come up with 2 equations. So with this equation, well, to get the number of points 30, I have to take 2 pointers, so I have to multiply this number by 2. So I have to take what x is and multiply it by 2. Then 3 pointers are worth 3, so I have to take this number and multiply it by 3. And then that should total to give you 30 points. So there's one equation that we can use to model this scenario. Okay? Then we can look at this scenario. So if I have to take y and do what to get x? Well, I have to add 5 to it because it's always 5 more. X is 5 more. Okay, so to get x, I have to add 5 to y. And that's really what we just did in these tables when we were thinking through it. So then, let's go down and we can plot these 2 relationships or these 2 equations onto this graph. So I'm going to use 2 different colors. I'm going to use purple, and I'll call this table A. And then I'll use a different color for table B. Okay, so I know that my x are 2 pointers, so I'm going to label my x-axis 2 pointers. And this will be 3 pointers. Okay, all right, so let's see. I have 0, 10, that's my first point, so that'll be up here. I have 3, 8, that'll be here. I have 6, 6, that'll be here. 9, 4, that'll be here. And that looks like as much as I can fit on this graph. okay? So I'm just going to connect my points here. And I'm going to label this line A, just so I know that that represents that table. Okay, I'm going to switch colors now and maybe use blue. I'll use a color you can see, orange. Okay, so I'm going to do table B in orange here. So my first point is 5, 0. So that would be 5 zeros here. I have 6, 1, 7, 2. If you look, it goes up like this. And then I can okay? All right, so if you notice, what happens when these lines are graphed on the same flat? You might notice that they meet in the middle here. So this is a special point, and this is when our lines or our situations are the same. Okay, so if you notice, he scores 30 points when he does 9 2-pointers and 4 3-pointers, and he also has 5 more 2-pointers and 3-pointers in this scenario. So this is the point that makes both of these situations true, which is the point we care about in the systems of equations, okay? So if you look, they cross at that exact same point that we found that they were the same in the table, okay? So that point is at 9 2-pointers and 4 3-pointers. So what happens with a line on the graph? They cross. Okay, so that is special because it tells us where these are the same. And then it says, can we check or verify that this point satisfies both of our equations? So we have a 0.94 that represent an x and a y value. And I have 2 equations here. So if they're the same, they should satisfy both of these equations. So let's check. So in this first one, 2x plus 3y equals 30. I'm going to plug in 9 for x and 4 for y. And this hopefully should be the same. 9 times 2 is 18. 3 times 4 is 12. Hey, look. This side equals 30 and this side equals 30. So that's true for that equation. In the second equation, y plus 5 equals x. I'm going to plug in, again, 4 for y and 9 for x. And I should get the same thing on both sides. And if you look, they are the same on both sides, which means this point makes both equations true at the same time, which is what we saw when our graphs crossed here and where our tables were the same up there. Okay, so systems of equations is all about looking where they are the same. You're given 2 types of constraints and you're looking for where they meet. So that is the first part of this video. You might be asked to check points like this or to come up with tables or scenarios in the following questions.